Have you ever looked at a bridge or a building and wondered how they make sure two massive steel beams are perfectly identical? I mean, how can you be sure two shapes are exact copies without measuring every single little thing? Well, today you're going to be a geometry detective, and together we are cracking the code of triangle congruence.
So here's our game plan, our case file, if you will. First, we'll figure out what this congruence thing is all about. Then we'll get our hands on the essential toolkit, the 5 rules that do all the heavy lifting. We'll also learn to spot the imposters, the traps that can lead you astray. After that, we'll put it all together to crack a real case, and we'll wrap up with a final debrief, basically the ultimate cheat sheet for your next exam.
Okay, detective. First things first, we need to know what we're looking for. So what in the world is congruence, really?
To put it simply, congruent means they're identical twins. They have the exact same shape and the exact same size. Think about 2 ATM cards from your bank, or maybe 2 brand new coins. If you could put one right on top of the other, they'd match up perfectly, with no bits sticking out. They're exact copies.
And for triangles, this is what it looks like. These two guys aren't just similar, they are congruent. Every single matching side is the same length, and every single matching angle is the same measure. You could literally pick one up, maybe flip it or give it a little spin, and it would land perfectly on top of the other one. A perfect match.
Now, this brings us to the detective's golden rule. You're going to want to remember this acronym, CPCT. It stands for corresponding parts of congruent triangles are equal. And this is the big payoff. Once you've done the work to prove 2 triangles are congruent, you automatically know that all their matching bits and pieces are equal too. It's a huge shortcut.
Okay, so measuring all 6 parts of a triangle, 3 sides and 3 angles, every single time, that's just way too much work. A good detective needs shortcuts, right? So let's build our official toolkit with the 5 essential rules for proving congruence. And here they are. These 5 rules are the only tools you're going to need. Think of them as these amazing shortcuts that let you prove 2 triangles are identical with just 3 key pieces of information. So let's take a closer look at each one.
All right, tool number 1, SSS, or side, side, side. This one's pretty intuitive, right? If you've got 2 triangles and you can show that all 3 sides of one triangle are the same length as the 3 sides of the other, well, they have to be congruent. Those side lengths basically lock the whole shape into place.
Let's look at SSS out in the wild. In this picture, we're told that side AB is equal to side CB. Cool, that's 1 pair. And AD is equal to CD. That's 2 pairs. But wait, what about the third side? Well, look closely. Side BD is part of both triangles, so it's equal to itself. That's our third pair. So boom, case closed by SSS.
Okay, next up is SAS, side, angle, side. Now for this one, we need 2 pairs of equal sides, just like before. But we also need the angle that's between those 2 sides to be equal. That's the key. The word included is everything here. It's like the angle of a hinge. It completely determines where that third side is going to end up.
And this diagram is a perfect example of SAS. See how side OA equals OB, and side OP is shared by both, so it's common. Now the angle we care about is the one literally sandwiched between those 2 sides, angle AOP and angle BOP. Since those are equal, we can confidently say these triangles are congruent by SAS.
All right, now this is a spot where a lot of people get tripped up. What's the deal with ASA versus AAS? For angle side angle, the equal side has to be the one included or squished between the 2 equal angles. For angle angle side, the equal side is one of the other sides, not the one in between. The best part, they both totally work. And why is that? Well, think about it. If you know 2 angles in a triangle, you can always figure out the third one, because they all add up to 180 degrees. So AAS can always turn into ASA if you need it to.
And our final tool is a specialist. This is RHS, and it only works for right-angled triangles. It stands for right angle, hypotenuse, side. So, if you've got 2 right triangles, and you can show that their hypotenuses are equal, and one other pair of sides are equal, that's it. You're done. They're congruent. So, a great detective knows which tools to use, but they also know which traps to avoid. Let's talk about the big imposters in the world of congruence, the ones that look like they might work, but don't.
So what do you think? Let's say you know 2 sides and an angle that's not between them are equal. Or what if you know all 3 angles are the same? Is that enough to prove congruence?
The answer is a huge, flashing neon sign that says no.
These are, without a doubt, the two biggest traps in triangle congruence, and you have got to train your detective's eye to spot them from a mile away.
So why do they fail? Well, SSA is known as the ambiguous case for a reason. With that information, you can often draw two completely different triangles. It just doesn't lock the shape in place. And as for AAA, well, that proves triangles are similar, which just means they have the same shape. It says nothing about their size. Just picture a tiny little equilateral triangle and a giant one. Same angles, right? 60, 60, 60, but they are definitely not the same size.
Okay, we've got our toolkit. We know the traps to avoid. I think it's time we crack a real case. Let's put all this knowledge into action.
Here's your mission, should you choose to accept it. We've got a square, ABCD. P is the midpoint of one side, AD. Your job is to prove that angle PCB is equal to angle PBC. I'm serious, hit pause right now, grab a piece of paper, and see if you can solve it with your new detective skills.
Okay, you ready for the big reveal? Let's walk through it. Step 1. Analyze the clues. It's a square, so we know all sides are equal, and all angles are 90 degrees. P is a midpoint, so AP must equal DP. Step 2. Form a hypothesis. If we could prove those two triangles on the side, PAB and PDC, are congruent, then we could use our golden rule, CPCT, to show that PB equals PC. Step 3. Select the tool. Well, we have a side, AP equals DP, an included angle, angle A and D are both 90, and another side, AB equals DC. That's a textbook SAS. Step 4. State the case. By SAS, triangle PAB is congruent to triangle PDC. Therefore, by CPCT, side PB must equal side PC. Which brings us to our final conclusion. In that bottom triangle, PBC, if two sides are equal, then the angles opposite them are also equal. Case closed.
Fantastic work, Detective. Before we officially close this case, let's have a quick debrief. This is the stuff you absolutely need to remember for your next mission or, your next exam. Here it is. Short, sweet, and to the point. Your 5 trustworthy tools. SSS, SAS, ASA, AAS, and the special agent, RHS. And the 2 imposters you need to avoid at all costs, SSA and AAA. Burn this into your brain. This is the key. And one last pro tip, this one's straight from the experts. Always, always, always mark up your diagrams. Use little tick marks on sides that are equal. Use arcs on angles that are equal. It's like taking a highlighter to the clues. It makes the evidence just pop off the page and helps you see exactly which tool you need to use.
So, we did it. We cracked the code of congruence. But here's something to think about as we wrap up. Now that you know how to prove triangles are rigid, unchangeable, identical shapes, how do you think that helps engineers build those massive, super stable bridges we drive over every day? That right there is where all this geometry stuff becomes very, very real.